Hey Nikki, here is a short video on how to do most of this stuff. So number one, we downloaded the file. This is the file, right? Let me make sure I got it in the right spot. Number two, go to variable view and ensure that female is nominal. So there's two parts to all SPSS data files. This is the data file. It ends with a .sav, right? There's a variable view. That's where you name your variables and describe them. The data view is where the numbers go. Okay, so variable view, she wants you to change female into a nominal variable. So there's that part. Number three, split the file. So we're going to go split a file. What you do there is you go to data, and way down here off the screen you can't see, it is 1, 2, 3, 4 from the bottom. It's called split file. Split file, not split into files, just split file. Click on that. You get this. And we're going to compare groups by splitting the female groups. What that's going to do is anytime you ask for anything on SPSS, like the descriptives or a histogram or something, it's going to give you one set of data for every group that's in that female variable. Okay, I'll show you here in a second, but you click OK. And then this is your output file. And this is where all the charts and the graphs and the tests will all come out on this one. So this is a .spv. So two files. SPV, that's output. Remember the P is output, SPV. And input, this is your SAV. That's the one with the numbers on it. So let's go to town. So I'm a little bit confused. Here's number three. It says split the file, what we just did, and it says ask SPSS to compare the groups. Okay, that kind of confused me, but I think what she wants you to do is run the histograms on these variables. Write, science, and turn on the display normal curve for each. Okay, let me show you how to do that. We're going to go to Analyze, Descriptive Statistics, Histograms. Histograms are all over the place, but this is where I normally get them. Explore, and she wants right. I'm going to put them in there. Right, and science. And so there's one way to do a histogram. There's other ways to do histograms. If this isn't what she's looking for, I'll show you the other way. And normality plots with the tests. And this will pop up. Yep. Give it a second. And so it takes a while to eat a crocodile. But here is all your data. And it's going to do two separate groups for the females, right? So female 0, 0. Here's all the writing score mean, the science score mean. Here's the one female. I'm assuming 1 means female and 0 means male, but I'm not sure. And again, it breaks down all the data into the separate groups. Here's your test of normality for the different groups, and they both violate the assumption of normality. Here is the female 0. That data is kurtotic. That means too many spikies. And here is the females marked with a 1. This is both kurtotic and skewed to the left. It's a mess. All right, another way to do histograms is you go to graphs, legacy, all the way down here at the bottom of the histogram, and you're going to put the variable right. So you'll notice that the variables aren't the same names here. You right-click, you can have their variable names. This is their display names, their labels, okay? So you can switch it in any way you want. I'm lazy. So let's do right first, and she wants to display the normal curve on top of it, which I don't quite understand. We all know what the bell curve looks like. And again, it's not very normal. Let's do the other one. Out with you and in with science. She blinded me with science. So you get the exact same histograms, but it doesn't tell you if they're significantly violating the assumption, which both of these are. Where the first way I showed you does. It shows you the Kolmogorov-Smirnov test of normality or the Shapiro-Wilks test of normality. So those are a little bit more accurate. Okay, so now she wants you to unsplit the file. That is actually pretty important. Every time you split a file, you have to put it back together. SPSS will not do that for you. I've made a million mistakes. So go back to data, and it's all the way down here to split file, which is way off the screen. Sorry about that. But you get this, and you just hit reset. Beep. Hit OK. And so the split file has been put back together. And what does she want you to do next? Run descriptive statistics on locus of control, self-concept, and motivation. So we're going to go to Analyze, Descriptive Statistics. Now, there's three ways to get descriptive statistics: frequencies, descriptives, or explore. But I'm assuming she wants you to use the descriptive statistics function. So let's go there, and we're going to kick in the variables of, where'd you go there? Locus of control. Okay, right click. Let's get those things there. Locus, look, there it is. Locus of control. Self-concept. And motivation is switch in a nation. So you got to figure out which ones you want. We always get the mean, standard deviation, minimum, maximum. Yeah, what the heck. Variance is a good one. Kurtosis, skewness, don't care. We know they're both bad on these things. And that's it. Let's get the standard error. That's not a bad one. And why not the range? Click, beep, click OK. And you get the descriptives on the output here. Hold on while I scroll it up. And here's the descriptives. Da, 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 right? You got your range, which is your difference between your largest and smallest values, your smallest value, minimum, maximum. The mean, there's the standard. There's the mean statistic, and there's the standard error of the mean and standard deviation and the variance, et cetera, et cetera. So let's move on. Number 7, we're going to recode motivation. So high and low. Let's go to transform. We're going to recode into a different variable, or does she want the same variable? Normally, if I'm going to recode something, I'll make it a new variable just in case I need to go back to the old variable. So I'm gonna just call it I don't know, motivation recode or something. Let me put that in there. Okay, so the new variable is going to be called motivation recode, which means that the old variable will still be there. Again, just in case. And we have to change the values. So let me make sure I get this right. I always get it backwards. So high is going to be 1 to 5, 1 to 0.5. So the lowest through the value, that's going to be our low, right? So the lowest is 0, right? And we're going to go up to 0.49. So everything from a 0 to 0.49 will be 1. That's a low. And we're going to add. And then the other value is going to be 0.5 through the highest, which is 0.1, and that's going to be a 2. And that should be everybody, right? Click continue. And what are we missing? Oh, yeah, you got to click change or nothing's going to happen. And then you click OK. But now let's double check the actual numbers to see that we did get a new variable with 1s and 2s. There it is right there, right? 1s and 2s, right? 2 means high. So let's look at our motivation scales, right? So yeah, this is right. 2 is anything over 0.5, and there's a 0.3 that should be a 1. So yeah, we're good to go. So we split that file between highs and lows, and let's label it. So motivation, the new one we call recode, is going to be nominal. And we're going to name the values. 1 is low, and add, and 2 is high. Add, click. So what does she want you to do with those? All I got to do is read the instructions. So we're going to split the file that we just made and run the descriptives again for, I guess, locus self-concept. I guess. Hold on. Well, I can split the file. Data, all the way down where you can't see it, split file. Beep, 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 beep. And then we're going to use the motivation recode as our splitter. And now she wants run the descriptives again, right? Descriptives of who? It must be these. Locus of control, self-concept. Okay, so we're going to go to Analyze, Descriptives. And it should be locus of control and self-concept. I'm kicking that out, but everything else should be fine. And there's all your descriptives. So we have more than what she's asking for, but there they are. There's the low descriptives and the high descriptives. All right, don't forget, whenever you split a file, you got to unsplit a file. So we go to data, all the way down to split file off the screen, and we hit reset. Boom. So everything's back to normal. Next, she wants a scatter plot between science and right. There's several ways to do that. Excuse me, we'll do them both ways. We'll go to graphs. Legacy dialogues has everything you practically need in there. We're going to go down to Scatterplot, and we're just going to do a simple define. And your x-axis, she says science and right. So normally science, whatever the first variable is the x. So science will be your x-axis, and right will be your y-axis. And that's all you got to do. And you're going to get a scatter plot. Look at that scatter plot. Oh, my goodness gracious. So now with this one, you could double click on it, and it pulls up the chart editor. There's a lot of stuff you can do here. Normally, you just put a best fit line in there. Boom. And you get this guy. Boop. And there's the straight line, and it's going to give you a lot of information, which I already did. So there is the best fit line to your scatter plot. There is your R squared, 0.324. This number, this in here is the equation to that best fit line, just in case you were curious. Right? But she wants you to use the chart builder, so let me show you how to do that. You're going to go to, how are you going to do that? You're going to go to the chart builder, and don't care. So you're going to use, what you do is you pick a scatter, you pick what you want down here, and I think that's a scatter plot. No, it's an error bar. Where are our, there's a scatter dot right there. So if we're just doing, one variable against another, we drag that up there. And I'm going to check her homework to see what she wants. So select science variable and drag it into the x-axis. So she wants science into the x, and that means writing must go into the y. Boop. And that's all she wrote, said to go. You should get the same thing. And that's it. That's all she is. All right, I'm going to put this together and send it to you. All right, talk to you later. Ciao.